So thanks to everyone for joining us for our virtual speaker series for February. We are very excited today to welcome Ashley Hall as our virtual speaker. So just to give you a little bit of background on Ashley, she earned her Bachelor of Arts in Anthropology and Animal Behavior from Indiana University. Then she spent nearly a decade working as a science educator for various educational institutions in California, including the Natural History Museum of Los Angeles and the La Brea Tar Pit. So during that time, Ashley also served as an assistant curator of paleontology at the Raymond M. Elf Museum of Paleontology in Claremont, California. She also then relocated to Ohio, where she worked as a naturalist for the Cleveland Metro Park Reservation System before taking a position at the Cleveland Museum of Nature as an adult programs coordinator. And so Ashley, of course, has got a lot of experience doing public outreach in paleontology and, of course, is a paleontologist herself. So we are very excited to welcome her today. Just a couple of housekeeping notes. We will have a little bit of time for questions afterwards. So if you're joining us today on YouTube, if you just want to type your questions into the chat, we'll address those at the end. And so with that, I will mute my microphone, turn off my video, and I will let Ashley take it away.
All right. All right, we ready? All right, good to go. Well, hi, everyone. My name is Ashley Hall, and I am here in the E.L. Wiegand Digital Learning Studio at Museum of the Rockies. And here at Museum of the Rockies, we are in Bozeman, Montana, and I am happy to present today a really cool program of some of my newest research, co-authored research with a few amazing co-authors. And so we should just dive right in. So today we're going to be talking about the ultimate Ichthyosaur. This is my newest publication about these fascinating Mesozoic marine reptiles. So again, I'm Ashley Hall. I am Outreach Program Manager here at Museum of the Rockies, and I have the best job in the whole world because I get to do outreach. And so as a paleontologist, I think we all love sharing facts and knowledge about our favorite prehistoric animals. And so I've been doing that since I was about 4 years old. This is me on the left in the Two Medicine Formation here in Montana, out at the famous site that Museum of the Rockies owns called Egg Mountain, made famous by Jack Horner and lots of different authors over the years. And then on the right, I'm holding a piece of coprolite from Egg Mountain. That is a dinosaur poop right there. Really cool, rich in fiber. And Karen Chin has done a lot of research on these coprolites. Here's my studio that I'm sitting in today. I had the pleasure of designing this virtual studio, this virtual learning space so that we can reach kids not only across Montana, but across the country and the rest of the world, as virtual learning has not stopped since about 2020. I also am in charge of our outreach kit program, and this outreach kit program is really robust. We send kits that have fossils and rocks and specimens and all sorts of things such as furs and skulls across to different teachers who use it for their curriculum. So I get to design those and help teachers across the state. Now here at Museum of the Rockies, we have an awesome museum. We're known for basically 2 or 3 main subjects. We are known for paleontology. As you can see there, we have a 40-foot long bronze T-Rex outside the front of our museum, known as Big Mike, and the original of this skeleton is now at the Smithsonian Museum in Washington, D.C. It is now known as the Nation's T-Rex. We also are known for our Montana history and for our planetarium. We have the only planetarium in the state of Montana. So raise your hand, a virtual hand, if you've heard of ichthyosaurs before. I'd like to see how many people use the chat as well to see how many of you actually know what ichthyosaurs are? And take a look at this photo and shout out some of the names of toy animals that do not belong in a bag of dinosaur toys. Well, as you probably know, because you watched this awesome series, everything that is extinct is not a dinosaur necessarily, and ichthyosaurs are not dinosaurs. While ichthyosaurs lived at the same time as dinosaurs for the majority of the Mesozoic, and both evolved from the reptilian lineage, The two evolved and diverged after the end Permian extinction 252 million years ago. Ichthyosaurs are more closely related to lizards and snakes, while dinosaurs are archosaurs, animals that are most closely related to birds and crocodilians. Again, here they lived in the Mesozoic. Beautiful art by Ray Troll, our buddy. He's an awesome paleo artist, in case you don't know Ray. He has the Cruise in the Fossil Freeway book and a few others. Be sure to visit his art. So while ichthyosaurs superficially look like dolphins, they're separated from dolphins by 200 million years. One of them is a reptile and one of them is a mammal, but they look incredibly alike. This incredible biological phenomenon is called convergent evolution, the evolutionary process in which unrelated organisms from different evolutionary lineages evolve structures, traits, or morphological features that have the same function due to environmental and ecological pressures. So while they look similar, they're just kind of doing the same things in the same sorts of environments. Ichthyosaurs swam the world's oceans for 160 million years, and this is a phylogenetic tree of ichthyosaurs plotted against geologic time, with time progressing from the left to the right. The most basal or earliest ichthyosaurs evolved in the lower Triassic, about 250 million years ago, while dinosaurs were evolving on land. The most basal or earliest ichthyosaurs started out small, so no bigger than a meter long, and through time exploded into a variety of different sizes and morphologies. This illustration shows several early ichthyosaur relatives that have been discovered in the fossil record. Chaohusaurus, which is pictured on the left there, exhibits the traits that are typical for direct ancestors of ichthyosaurs, including live birth. And here, this picture is a beautiful paleo art reconstruction of Chaohusaurus by my favorite paleo artist, Gabriel Ugato. On the right, you can see the bones of its tiny embryo in yellow, right down there. So cute, so small. Incredibly, many ichthyosaurs have been found with embryos inside of the body cavity, and most have died before or during birth, as birth to live young is extremely taxing on the mother. This beautiful specimen of Stenopterygius died before or while giving birth. So sad. Baby and juvenile ichthyosaurs had adorable, comically large eyes, as the eyes of vertebrate animals don't grow. Our eyes are the same size from the time we are born to the time we're an adult. Scleral rings are rings of bone found in the eyes of many animals and several groups of vertebrates, except for mammals and crocodilians. They can be made up of single bones or multiple segments. They have a role in supporting the eye, especially in animals whose eyes are not spherical or which live underwater. And I threw a pineapple ring right on top of this because it really reminds me, especially in the way that they separate, it reminds me of a pineapple ring. So fun activity for kids in case you want to make like a cottage cheese pineapple ring, ichthyosaur, something like that. This simplified phylogeny of ichthyosaurs shows the best known and most characteristic genre. The first ichthyosaurs evolved in the early Triassic, like Chaohusaurus, but became more diverse and both small and huge in the middle and late Triassic. So Mixosaurus there is really teeny tiny, and Shastasaurus is the really insanely big one. So in the Jurassic and Cretaceous, many ichthyosaurs had a similar fish-like form, but maintained a high diversity of sizes and niches. Now, the largest ichthyosaurs could be as large as blue whales, just about, maybe a small blue whale, and the smallest were only a few feet in length. This is my co-author, Dean Lomax, laying next to the Rutland sea dragon, which is a monstrous ichthyosaur discovered in 2021. And here's a picture of Dean. He is a very large guy. If you've ever seen or met him in person, he is absolutely phenomenal. Great educator, awesome paleontologist, but he's about 6'2", I want to say. He's a big guy, so this is a huge animal. What's really cool is by looking at melanosomes, or cells that contain pigment preserved in feathers and skin of some spectacular fossils, paleontologists have been able to reconstruct the colors of some extinct animals. And we now know, for example, that some dinosaurs had stripy tails and face masks, spotted wings, and even iridescent bodies. In this ichthyosaur, melanosomes were analyzed by using a very high-powered electron scanning microscope. And to do this, pieces of the skin had to be removed from the fossil and coated in a thin layer of gold, which reduces the buildup of static charge in these powerful microscopes. The study allowed researchers to know that this ichthyosaur, get ready for it, was counter-shaded, dark on the top and light on the underside, like many marine animals are today. So if you think of something like a shark or a whale, they often have coloring that is darker on top and lighter on the bottom. So here's a big question. So why did they go extinct? They were an incredibly successful group of animals, but the demise of ichthyosaurs has been described as a two-step process. A first extinction event in the beginning of the Cenomanian eliminated 2 of the 3 ichthyosaur feeding types. It eliminated the soft prey specialists and the generalists, leaving only an unspecialized apex predator group. The second extinction event took place during the Cenomanian-Turonian boundary event, a marine anoxic event, after which just a single lineage survived, which is Platypterygius, which then disappeared about 93 million years ago. Ichthyosaur extinction was a pair of abrupt events rather than a long decline, probably related to environmental upheavals and climatic changes in the Cenomanian and Turonian. Competition, though, this is a really interesting thing with early mosasaurs, is unlikely to have been a contributing factor, since large mosasaurs did not appear until 3 million years after the ichthyosaur extinction, filling the resulting ecological void left by the extinction of ichthyosaurs. So while mosasaurs and ichthyosaurs were sort of living around the same time, they did not seem to have competition with one another. This part of the Cretaceous was one in which many other marine extinctions occurred, including those of some types of microplankton, ammonites, belemnites, and reef-building bivalves. The Mesozoic seas were full of incredible creatures who all evolved, thrived, and died out over millions. How were ichthyosaurs first discovered? Let's dig into their history. So the name Ichthyosaurus, as many of you probably know, means fish lizard, and it appeared for the first time in 1817 in the 12th edition of A Synopsis of the Contents of the British Museum, a booklet designed for self-guided tours of the museum. Scientists thought that these fossils represented fish remains, and in 1708, the Swiss naturalist Johann Jakob Schlosser described 2 ichthyosaur vertebrae, assuming they belonged to a man drowned in the universal deluge. In 1766, an ichthyosaur jaw with teeth were found at Weston near Bath, and in 1783, fossils were exhibited by the Society for Promoting Natural History as those of a crocodilian. In 1779, ichthyosaur bones were illustrated in John Walcott's descriptions and figures of petrifications. Toward the end of the 18th century, British fossil collections quickly increased in size. Those of the naturalists Ashton Lever and John Hunter were acquired in total by museums, and later it was established that they contained dozens of ichthyosaur bones and teeth. The bones had typically been labeled as belonging to fish, dolphins, or crocodiles, as you can imagine. They sort of look very similar, and the teeth had been seen and described as those of sea lions, which is pretty interesting because as humans, we really only can identify what we already know. So Mary Anning, who some of you may be very familiar with, my favorite paleontologist, was an English fossil collector, dealer, and paleontologist who is now known around the world for the discoveries she made in Jurassic marine fossil beds at Lyme Regis. Her fossil findings contributed to changes in scientific thinking about prehistoric life and the history of the Earth. Some say that children's rhyme, if you've heard of She Sells Seashells by the Seashore, is about her, as she used to sell fossils to make ends meet for her family. But this has never really been confirmed. So Mary Anning and her family's first well-known discovery was in 1811 when Mary, at just 12 years old, and her brother dug up a 4-foot ichthyosaur skull, and a few months later, she found the rest of the skeleton. Henry Host Henley of Sandringham House in Norfolk, who was lord of the manor of Colway near Lyme Regis, paid the family about 23 pounds for it. And in turn, he sold it to William Bullock, a well-known collector who displayed it in London. There it generated interest as public awareness of the age of the Earth and the variety of prehistoric creatures was growing. It was later sold for 45 pounds and 5 shillings at auction in May 1819 as a crocodile in a fossil state to Charles Koenig of the British Museum, who had already suggested the name Ichthyosaurus for it. As a woman, Mary Anning was treated as an outsider to the scientific community, unfortunately. At the time in Britain, women were not allowed to vote, hold public office, or attend university. The newly formed but increasingly influential Geological Society of London did not allow women to become members or even to attend meetings as guests. The only occupations generally open to working class women were farm labor, domestic service, and work in the newly opened factories. Although Anning knew more about fossils and geology than many of the wealthy fossilists to whom she sold, it was always the gentleman geologists who published the scientific descriptions of the specimens she found, often neglecting to mention that she was involved at all. They never included her name. She became, of course, very resentful of this, and Anna Pinney, a young woman who sometimes accompanied Anning while she collected, wrote, "She says the world has used her ill. These men of learning have sucked her brains and made a great deal of publishing works, of which she furnished the contents, while she derived none of the advantages." Anning herself wrote in a letter, "The world has used me so unkindly. I fear it has made me suspicious of everyone." Mary died of breast cancer in 1847 at the age of 47 and was only appreciated years after her death. A statue, which been erected in her name, and it overlooks the cliffs that she once explored. We all wish that Mary could see how she's perceived in our modern world now as a hero and revered in the highest regard. Myself and several other paleontologists and supporters helped fund this statue at Lyme Regis in her honor, and I still have yet to see it, so hopefully I can make a trip over there someday. Mary Anning's contributions inspired this piece of paleo art here, Duria Antiquior, one of my favorite pieces of all time. Henry de la Beche painted this piece in 1830. Notice the massive amounts of fossil poop or coprolites in this photo, as coprolites have been found in massive quantities on the Jurassic coast. In 1855, natural history artist Benjamin Waterhouse Hawkins unveiled these dinosaur sculptures in 1854. These were the world's first full-scale reconstructions of dinosaurs and represent the first 3 species discovered. These incredible discoveries inspired many fun and cheeky pieces of paleo art, including these gems. Take a look here. These are just so fun. We don't quite have anything like this anymore. I just love how fanciful they are. The discovery of complete fossilized skeletons around Lyme Regis was a turning point for the new science of paleontology. Ichthyosaurs emerged from the depths of time and provided us with a snapshot of just how alien our world once was. They became a global sensation, and even several large concrete ichthyosaur models were erected in Crystal Palace, alongside dinosaurs and other prehistoric animals in 1854, and amazingly, still can be seen today. Ichthyosaurs from England and Germany can be found at many museums worldwide. Ichthyosaurs today have not been featured in pop culture as much as their dinosaurian cousins, like in Jurassic Park or Jurassic World, but they did get a beer named after them. Here's my co-author of this study at the NHM London, looking at all the beautiful specimens from the Victorian era. If you travel, make sure to look for them in museums. Speaking of museums, here's a brief look into one of the most incredible collections of ichthyosaurs with naturalist, everyone's favorite, David Attenborough. So where does my story begin? So in January 2017, especially with, how we got a hold of this project, in January 2017, my co-author Dean Lomax visited the collections of the State Museum of Natural History in Stuttgart and examined a replica ichthyosaur forefin and hindfin. The associated label said it was the original. The original belonged to a specimen of Ichthyosaurus from the Lower Lias of Dorset, England. Parts of the specimen looked suspicious, so Dean visited the museum to examine the specimen further. Dean Lomax and our other co-author here, Sven Sachs, are looking at the specimen here, but something didn't quite look right. Little did they know that the specimen would be a Frankenstein specimen. It was so intriguing that Dean and Sven decided to publish on it and asked me to co-author, to which I happily agreed, as Mary Anning has always been one of my heroes, and to work on was a complete dream. The skull seen here, if you look closely, turned out to be entirely fake and carved from plaster. However, detail in the carving of some of the elements appears realistic and shows that the time and effort was put into constructing the skull fairly accurately. Portions of the skull have multiple scalpel lines expanding across it, which may have been intentional to provide detail in the surface of the bones, but do not match what is expected for the authentic specimen. The shape and structure of the skull suggests it was probably based on an original Ichthyosaur skull, as a large eye and long snout are somewhat reminiscent of the lower Jurassic genus Leptonectes, known primarily from Dorset and Somerset, England, and which would match the initial identification written on the label of the SMNS replica. Almost all of the teeth, except for a few poorly preserved original teeth under the maxilla, are made of plaster. The detail appears somewhat anatomically accurate, which might indicate that some of the copies of real teeth are positioned at different angles. Almost all the ammonites here, the spiral-shelled cephalopods related to octopus and squid, are embedded in the matrix. But where are they from? Ammonites are great index fossils, and index fossils help date other fossils that are found in the same layer of marine rock. These cephalopods are abundant, widespread, and various species live during distinct time periods that can be easily identified by their shape and suture patterns. And you can see there, the pictures above the Ichthyosaur are the ammonites that were found within its matrix. Now, to give an example of index fossils, bear with me, everyone. I am a huge, there we go. Oop, there we go. I'm a huge Swiftie, surprising no one if you follow me on social media. And I'm able to identify Taylor Swift's era based on her hair, clothing, and appearance alone. These different looks correspond with her different eras, just as ammonite morphology corresponds with different geologic eras. Is anyone here able to identify any of these eras by sight alone? Well, if you can, you might know that her eras correspond with different years in a chronological timeline, as seen here. So if Taylor's in a purple dress or wearing purple, you know it's Speak Now. If she's in red, it's the red era. And if she looks like she is a Victorian woman outside in the forest, it is the folklore era of 2020. So the first ammonite is embedded in the matrix adjacent to the pelvis. And based on morphology and preservation, it is likely an Asteroceras ammonite that is known from the Upper Sinemurian, Lower Jurassic of the black Venn marl member from Dorset. The preservation of a second ammonite, along with surrounding sediment, are typical of Holst specimens from Germany. This is a small, immature, hildoceratid ammonite, perhaps the Hildates-like form, which confirms this matrix block is from somewhere in the Middle Posidonia shale. And there's a third ammonite positioned immediately posterior to the skull, but appears to be set into plaster rather than matrix. The morphology does not match any of the more typical specimens found at Holzmaden, and again, based on morphology and preservation, is similar to Caenestes from Charmouth, which would place it in the lower Sinemurian of the shales with beef and black Venn marl members. In any event, as this ammonite is not in its original matrix and does not offer reliable stratigraphic information about the Ichthyosaur, it contradicts the stratigraphic details of the ammonite found in situ of the hindfin pelvis block. So this specimen contains 2 ammonites from Charmouth and 1 specimen from Germany. There we go. There we are. So right away, you can tell that these ammonites were not in their original position and were indeed placed within a fake matrix. So by looking more carefully, there's a distinct color between the matrix containing the hind fins and pelvis and the matrix surrounding the entire specimen. All right. So the hind fins. So the hind fins and pelvis are authentic, thank goodness, and appeared mostly complete. Whether they belong together might be questionable based solely on the composite nature of the rest of the specimen. However, the proximity and contact of the pelvic bones with the hind fins suggests that they are from the same individual at least, which is good. Based on the morphology, we assigned the hind fins to Ichthyosaurus conibere, only known from 2 specimens, one complete, seen here, and the partial holotype. There we go. There's Ichthyosaurus conibere. And there's the hind fins. So the vertebral column is mainly composed of caudal or tail vertebrae of an unknown number of individuals and taxa. Given the lack of data for the specimen and the lack of any obvious defining characteristics of the vertebrae, we aren't sure about their provenience or specific identification. However, considering that the matrix block the skeleton has been purposely set into comes from the Holzmaden area, the Posidonia shale, and given that Stenopterygius is common at Holzmaden and the color of the vertebrae matches the other bones from Holzmaden, it appears likely that they're from multiple individuals of Stenopterygius from this location. So this Frankenstein specimen is unique for several reasons. It is, to our knowledge, the first Ichthyosaur composite comprised of material from 2 different countries, Charmouth, Lyme Regis, and Dorset, England, and Holzmaden, Germany. It's also the first documented composite ichthyosaur to be made up of specimens from 2 different geological stages. The Dorset specimen is from the Sinemurian, so 190 to 199 million years ago, whereas the German material is Toarcian, 182 to 174 million. The skull is entirely carved from plaster, although parts might be based on real specimens. Likewise, the forefin and coracoid are possibly replicas of an original specimen. So the specimen comprises real hindfin and pelvic material, like I said. And to put this in perspective, this would be like combining T-Rex with the Spletosaurus that lived 10 million years apart in North America. So, you know, it's like a really big deal in dinosaur paleontology if things like that would be combined. And, you know, to put in perspective, that would be like combining these 2 really big tyrannosaurs that lived 10 million years apart. So why did Victorians create faux fossils? Well, the goal for making Ichthyosaur composites in the Victorian era was likely to produce a more complete, visually clear specimen for educational or display purposes. Thus, these specimens are not frauds or forgeries, as are found in the commercial fossil trade today. In fact, many were donated, not sold, to museums. And we basically did this study because researchers need to carefully examine historic specimens, especially complete or nearly complete skeletons, to verify that it is, in fact, a single individual before conducting their research. A composite specimen is still extremely valuable scientifically, and historic specimens, especially from inland seas of Somerset, are largely from locations that are no longer publicly accessible. Often a large portion of the skeleton is entirely authentic, and this presents a wealth of morphological data that should not be ignored. Multiple criteria need to be considered in recognizing a composite, and with a careful assessment of historic material, a lot of valid information can be obtained. So here's a story that hit the press. It's a Jurassic lark, and dinosaur, quote unquote, is a hoax. We still see ichthyosaurs called dinosaurs, of course, in pop culture because people are not comfortable in saying marine reptile for some reason. Or ichthyosaur is not famous enough to kind of designate its own thing in a lot of the world. So until we get an ichthyosaur in Jurassic World, I think we'll continue to see them being called dinosaurs. So here's a good question. So why elucidate fossils? And for research, this is a really big deal. The ability to identify fake from real fossils in a single specimen, it's important, but a really difficult task. It's important to research the history of the specimen, if it exists, before describing unique morphological features or new geological information. In order for researchers to minimize future difficulties over publishing on Frankenstein specimens like these, we recommend a healthy dose of skepticism and research into the history of a specimen prior to study. So always know what you're studying. Overlooking the details and completeness of a specimen can lead to issues of credibility of researchers, which is not good, institutions, especially not good, and even paleontology in general, extremely bad. Besides experience, new and improved non-destructive technologies such as chemical analyses, X-ray or CT scanning, and the analysis of fossils under ultraviolet light enable researchers to distinguish skeletal elements in the surrounding matrix as added, sculpted, or carved more easily than ever before. And here's a really cool thing. This is a skull, and I can't remember which species this is off the top of my head, an ancient species of rhino. And what's really cool is under ultraviolet light, you can actually see the real bone versus what has been filled in versus the consolidants and all of that. So it's a really useful technology now to use ultraviolet light when trying to elucidate fossils that you may be publishing on. And with that, I thank you for attending, and thank you to the Philip J. Curry Museum for having me today. I love you guys. You are our neighbors to the north, and I hope I can answer any questions about ichthyosaurs. Also, big thanks to my co-authors, Dean Lomax and Sven Sachs, and thank you to everyone who's watched, whether it was live or recorded. Hopefully you guys learned a lot about ichthyosaurs today. All right, and with that, I will turn it over to questions.
Perfect. So thank you so much for that really
and you're
fascinating
muted.
talk. Oh,
there you go.
That's me. Okay. Thank you so much for that fascinating talk. It's really interesting to hear about something in paleontology that we don't always necessarily see about where specimens come from and that kind of thing. We do have a couple of questions that have come through the chat here.
Awesome.
So Kirsten is asking, is the matrix of the Iffyosaur made out of concrete or something similar?
Ooh, you know what? So it's actually they would take matrix and like grind it up and make it into a similar material. So it is in a way sort of like making concrete out of the matrix that it was once in, if that makes sense. So it's not concrete itself, it's actually a mixture of the matrix that has been sort of like made into to look like it's real. Yeah. And I did bring a couple specimens to show too, so I have some fun things.
Okay, cool. Another question here from Robert. Do locations in the UK and Germany make the two ichthyosaurs subspecies?
Oh, I think the answer is no. I myself have not as heavy of a background as Dean and Sven in ichthyosaurs, but these are two completely different specimens as they're from different time periods. So I'm not sure much further than that.
Okay. It's a question about the rhino skull, which I kind of find fascinating too.
Yeah.
It looks like kind of like an Eocene rhino, maybe. And so Robert is asking, does that rhino actually have the two large teeth pointing out? I'm curious too, because I've never actually seen one that actually has those two lower incisors, they probably be.
Yeah. So on ultraviolet specimens, the real bone is the sort of darker, how to describe it. It's not the like illuminated. The illuminated is the pieces that were added in. The real bone and the real teeth are the ones that are sort of like the darker color. So yeah, those are real. So cool, right?
Mm-hmm. A weird looking beastie.
And I can't quite read I can't remember which one this was, but the tag is very tiny.
Okay.
If you're interested though in looking more into ultraviolet light on specimens, it's really incredible because it takes away a lot of the guesswork. So when you're looking at adhesives, a lot of the adhesives that paleontologists back, 20, 30, 40 years ago have changed dramatically with fossil prep. And so by using an ultraviolet light, it actually illuminates those and makes them different from the surrounding fossil.
Another question from Robert here. Are ichthyosaurs more common in Europe than in North America?
just because of preservation bias, they are. Um, when you look at sort of biogeography of ichthyosaurs, they were in the world's oceans, but then we look at where they were actually preserved and when they were dying and being exposed and all of that. And the UK just has loads more than North America just because of that. And so the way in which they were preserved in these really fine sediment conditions where the whole body was preserved, like we see with the, I'll go back to the really beautiful ichthyosaur. Oop, hang on a sec. The really beautiful ichthyosaur from Germany. These are really common. Not that one. There we go. All right, so this one. Oop. Go away. What happened? Is that mine?
I think so.
There we go. Whoa. Haunted computer. Okay. There we go. So specimens like this were deposited in really fine sediment with incredibly, calm conditions, and none of the bones were really disturbed. So the baby being expelled there, most likely from gases built up in the body, really didn't go anywhere, even like the tiniest little vertebrae. And so Germany, that's why a lot are found over in Germany and England, because the conditions were just right. Although some of the biggest ichthyosaurs were actually found in Nevada. So Nevada state fossil, I think it's Shonisaurus, is like a whale-sized ichthyosaur, and it's absolutely massive.
Mm-hmm. I think there is also a giant one from the mountains in British Columbia as well, of all places.
Oh, awesome. Oh, cool.
The Shonosaurus.
Yeah, very cool.
So another question here. This is a good one. Do you think restoring fossils, like sculpting and painting missing parts, is helpful or harmful in paleontology?
So this is a really interesting question for both of us, right? Because it's like we can both probably talk on this. So the history of preparation, and if you are all interested in fossil preparation, you should have my husband Lee on, because he's the lab and field manager here at Museum of the Rockies, and he's actually diving deep right now into the history of fossil preparation. And you don't know what you don't know. And so when the fossil preparation first started, especially like in the Victorian era, they were making things look really pretty and really nice, like the specimen back here. Show you this one. So this, get my microphones out there. So this is a baby ichthyosaur that I obtained. It's a fossil cast, and so it's not the original specimen, but it is a cast of the original. And this is one example of, you don't just want a head, when you're a Victorian, like in your parlor, you want the whole thing if you can help it. And so if they were missing parts and pieces, they might try to make them look better, as any, human maybe would, because we want things to look good. And so with adding specimens like that, you have a tendency in the past to sort of like fill it in, make it the same color, take putty and like put it in and sort of, make it go away, right? And they didn't know that, 200 years later, that we would be looking at it going, well, wait, this isn't the same thing. They didn't know that research was going to come this far and that people were going to be looking at these things. And so over, the past 200 years or so, the history of fossil preparation has evolved just as the animals have. And so now in fossil preparation, when you have, when you have something like, this is a Maiasaura metatarsal. So this is our state fossil here in Montana. This is a beautiful foot fossil, but we've had to repair it over the years. It's our educational specimen. But if I go to my ceiling camera, you'll see here that it's been glued together, and maybe not in the best, most in the best way. It's sort of, maybe 20 years ago was fixed or something like that. But nowadays, what we do here at Museum of the Rockies is we would take some putty and fill it in and maybe make it a different color. So even having a different color helps elucidate and help people understand that it's not the real thing, right? So you can see what pieces are missing. Because if you were to look at this and you're a researcher going, you know what, I'll add this to my data set. So it's, this long and you're measuring it. And then later on, let's say you're going to be publishing it, you find out that this bottom half was actually painted and it's not the real thing at all. So then that totally wipes that part of your data. And so the answer is many museums tackle this in different ways, but I feel like, and maybe you can speak to this as well, museums are sort of making their cast different colors. In Museum of the Rockies here, we have a Triceratops on display called Yoshi's Trike, which is sort of like white and brown to show what's real and been found. And our T-Rex is like that too. What about specimens at your place?
Yeah, so we also have specimens that have pieces filled in, and we sort of do the same thing. Like the bone is brown, and it's usually a plaster or epoxy infill, which is a different color so people can see. And then we also in our museum label real specimens, casts, and composites, just so that the public is aware that what they're looking at may not be the real thing, but it's a cast of the real thing. And so that is helpful because it allows us to showcase more specimens.
Yeah. And I think, there are in our research paper when we were writing this, we were talking about towards the end in the discussion, fake fossils versus like intentionally faking them to sell them. There's a big difference between a historically, kind of mixed up Frankenstein specimen that has some pieces that have been filled in, pieces and parts to make it look better, versus someone who is actively trying to take, let's say like a lot of specimens that are bird-like, so like Archaeopteryx, sort of beautiful feathered animals, are really hot right now, right? And so, people are trying to maybe actively fake them, try to sell them to researchers or museums. And so now, luckily, people are catching on to that, and we're getting technology to help prevent that sort of thing, because that will hopefully stop a lot of that fossil forgery and the need to sell fossils. But yeah, it's an ongoing thing. It's still evolving.
Work in progress. So another question from Kirsten. Is there likely to be a correlation between size of a species and size of the ocean or the environment, I guess, they were living in?
Is that sort of like when you keep a turtle in a tank this big, it stays this big? That's what it makes me think of. Thanks for your question. Yeah. So, the size of the early ichthyosaurs, like I said, they were like, a meter long, so they're not very big. And there was nothing in the ocean at that time that was a vertebrate that was that big. They were literally the first animals to have, that great of a size. And so you see this really interesting boom, this explosion of ichthyosaurs right after the biggest extinction that the Earth has ever seen. So, the Permo-Triassic extinction, which wiped out 90% or more of life. And so there was nothing there. All of a sudden, these little, sort of terrestrial, their ancestors were terrestrial, took to the water, and they found, probably ample amounts of squid and fish and things that were, reproducing, and they were having their big boom. These little lizards, took to the sea, and they said, wow, this is an amazing buffet. And so you see the sort of bigger, let me go back to my PowerPoint here, the bigger explosion of a lot of these ichthyosaurs. There we go. Let's go to the body size slide. Yeah, so they start small, they get big really, really quickly within 3 million years or so. And here's some little body sizes. This also happens with mosasaurs and whales. So throughout, you see these sort of like aquatic progressions into the sea from the land. You've got things like ancestors of whales, which are these small furry looking things that are sort of otter-like and sort of carnivorous like otters, but also kind of wolf-like. And they take to the ocean. And that niche has been opened up after the Cretaceous extinction because mosasaurs are gone. So after the Cretaceous extinction, 66 million years ago, wiped out mosasaurs, the ocean is open again, free game. And then you get these little, again, terrestrial animals going down to the water and saying, hey, there's nobody else here. I think this is pretty cool. So they're going down into the water. Whales explode. They get enormous again, too. And so it happens again and again. But you know, throughout the history of ichthyosaurs, it's not like all ichthyosaurs got big. You still had those niches that were still in place. So I guess the answer is no. The size of the environment does not determine the size of the animal.
Mm-hmm. It's interesting how that works.
Yeah. And I often wonder too, I'm always like, what is the next thing? Like, what is, you know, whales aren't going to be around forever. There's got to be a next thing in like 2 million years. So like, is it going to be cephalopods? I'm like hoping, I'm hoping for cephalopods. Just make the squid and octopus super giant, bring them on land.
Snails, like giant snails.
Yeah,
Dr.
I'm good
Dickens.
for a snail earth.
There's time for just a couple more questions here. An interesting one about stomach contents. So have there been ichthyosaurs with stomach contents? And because they're usually depicted as feeding on ammonites or some kind of other cephalopod.
Absolutely. So along with having their embryos found with them, did I not include one? So there's the embryo again. So when you have this really beautiful fossilization where no bones are disturbed and it's a very quiet, calm environment of deposition, you get these really beautiful babies. There's the baby again. And then there are stomach contents preserved, I believe. And actually, let me switch to this camera again. I'm going to get this big one underneath the camera so you can see it. Because I was told by my co-author, I don't know a lot about this little one. I have an ichthyosaur paddle here too, I'll share with you. But this one I've heard has stomach contents. Let's see if we can see them together. All right. So let's see. There we go. And bear with me, I'm gonna grab my remote here. All right, so in my fancy studio, I have many camera angles. So I have the front angle, I have the ceiling angle with the remote, and the side angle. So let's go to the top camera. All righty. And we'll swing the camera a little bit. There we go. Cute little guy. All right, let me zoom in here. Take a closer look. So the real specimen again of this is overseas in the UK. Right, and I don't believe this one has been published on yet, but these look like bones from probably another paddle. I want to say it's somewhere, so this is the rib area. Yeah, I'm not exactly sure. I can't see any immediate fish bones or anything like that, but in the guts of ichthyosaurs, you can see these under different kinds of light and different, you know, ways of studying it, but not sure about this one, but isn't it cute? It's a cute little thing.
So cute.
And again, this specimen is very small. So if this were a baby ichthyosaur that was alive today, this would be a cute little guy kind of swimming along. And the eye, by the way, of this animal is enormous. So for its head, this is the size of its eye. It's like the size of a golf ball. So really big.
It's a question about, is that one of Fien's finds?
What's that?
The question is that one of Fien's finds? F-I-A-N.
Oh, yes.
Yes.
Yes, that's his name. It was.
Nice.
Yeah. And that is overseas. He has that. And I was able to purchase a copy from him. Yeah, he's an amazing collector overseas. And then I'll show the paddle I have here. This is an ichthyosaur paddle. So if you're not familiar with ichthyosaur hand morphology or flipper morphology, this is what their hand looks like. So they have many, many bones in their hand, and you can see these are formed, and sort of like found like this, but then also there's little bones that'll roll out and be found like this on the beach.
A lot of bones.
So many bones, way more than us. So if you want to learn more in depth about Dean's research, Dean Lomax is the ultimate ichthyosaur guy. He's extremely available on social media if you want to, message him about any of that. And he has a bunch of talks as well, I think, on YouTube. So he's an awesome guy.
We'll have to get him on here.
Yeah, absolutely.
That'd be cool. I have a question about gastroliths, like stomach stones. Do ichthyosaurs have stomach stones?
Not that I'm aware. They do. So I didn't answer the question from before. So ichthyosaurs have been found with gut contents, and they have been found with fish and things like beaks of cephalopods in their stomach. And so those have been found. I don't know about gastroliths, so maybe that's a good question for Dean. They are found in theropods and plesiosaurs and things like that, but I have not heard of any ichthyosaur gastroliths. Interesting.
Time for just a couple more questions here. I saw the one that was, one about, because we are talking about kind of filling in like Frankenfossils, are there laws against fossil forgery?
I wish there was. I don't think there are. Are there?
I'm not sure. There's certainly laws around selling.
Yeah. I don't think there
fossils.
are laws on fossil forgery. Yeah. I mean, there's laws against selling, exporting, but I haven't heard any. If you do know of any, if anyone out there, type it in. But in my many years of being involved in paleontology, I've never heard about it. I think it's just done under the radar and done in a very like shady way, and sold on the black market and to people that don't know how to recognize fossil forgery. So it's a very sneaky profession. And the things that museums do when we are, working to actively, like I said, like fill in gaps in the bone, that's just helping preserve them for the future. And we use reversible things like adhesives, reversible materials, so that in case, the next generation in 50 years says, why did they use, this sort of putty that's incredibly destructive or something like that we didn't know now, they can reverse that in the future. So different than fossil fakery. Yeah, and I think one of the problems is people purchasing fossils that they believe are authentic when they've actually been fabricated. Like I know one of the common ones is they'll sell mosasaur jaws and the teeth are real, but then the jaw part isn't, but they're sold as legitimate. I hate it. I hate it so much. So there's a lot of that out there. I'm on social media and I'm happy to answer questions of things like that. I had some people at the Tucson Gem and Mineral Show who were there and just didn't know what they were looking at and asked me if things were valid. And, because the seller's not going to tell you that it's fake or that any part of it was filled in if they're not, what's the word? If they're just trying to make a profit, right? They might just say, yes, it's real. I found it just like this. But to the trained eye, someone who has been in the field for a very long time and knows that those sorts of things are faked. Those crocodilian skulls that come from Morocco, trilobites from Morocco, even fossil fish and things like that, they can be really well faked. And the people who are just, going to a fossil gem show or something like that for fun, maybe just see something, they're like, oh my gosh, this is a great deal, let me pick it up. And then while it might have some, sort of like real mosasaur or real crocodilian teeth, that's all you're getting. You're only getting like 3 out of like a skull this big or something like that. So if people are out there wondering, maybe they want to buy a fossil, or maybe they, want to start a collection for their child or something like that, I always recommend fossil casts. So I was able to purchase this beautiful ichthyosaur that I never would have been able to. That's an exact copy, research quality. It's got all the pieces and parts that the original does. And there are many different sellers out there. So maybe we can link to those, your favorite ones in the program. But there's many different places that cast and make amazing copies that are super affordable. You can get, things like this La Brea skull from the La Brea tar pit. So this is a Smilodon or saber-toothed cat copy. This was maybe $300, and it is an actual cast of the real thing that's found at La Brea, and you don't have to take it from, the collections of where it is. The dodo back here, by the way, and actually everything behind me on the shelves is a fossil cast, including the skeleton, because, I'm a museum teacher, and so I want everyone to be able to handle and be able to touch everything that I hand them and have it not fall apart, because the saddest thing is to hand someone, a real skull and part of it falls off. They're like, oh my God, I broke it. And you're like, no, 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 it's fine. So I recommend fossil casts for sure.
Yeah, we also have, well, the MOR probably as well. We have a 3D printer, so we can 3D scan and 3D print fossils too. Like this T-Rex back here is Scotty, the big Canadian T-Rex, and that's a scale model of the specimen.
Yeah, that's the thing too. Like 3D printers have come so far. So where, they once had the sort of lines where you could see where they were printed, now resin printing has really changed the game, and it prints an exact copy with no lines, and it's just like a beautiful representation of the real thing. So, this dodo behind me was 3D printed. It's made of, I think, 12 different dodos from Mauritius. But I was able to get it at a really good price. It's 3D printed, and it doesn't hurt the fossil trade or science. So get you some replicas or some 3D prints.
Thanks. So just a note from Paleo Guy here says, to my knowledge, no laws exist that dictate restorative practices in fossils.
Perfect. That's my husband. Hi, Lee.
Oh, okay. Hi, Lee.
So Lee is the preparator lab and field manager here. So yeah, there's no laws. So maybe there should be.
It's cool.
Although how would we police that? I don't know.
It's true. And a lot of these things are hard to police, which is part of the problem. So we are at 1 o'clock. So thank you so much to Ashley for this really amazing talk. If you missed it live, it will be up on our virtual speaker stream on our YouTube channel. So thanks again to Ashley for your time and for the talk, but also the great discussion afterwards.
Oh, thank you too. I love you guys, and I hope to come up even farther north than we already are and come visit you. And you're welcome here at Museum of the Rockies anytime.
Oh yeah, for sure. It's on my bucket list. I've never been, but it's definitely
come on down
for sure. So thanks to everyone for watching. Our next virtual speaker series is March 16th, and we are having Sally Hurst from New South Wales in Australia talking to us about Australian fossils. So we'll hope that you'll be able to join us for that as well. So thanks again to Ashley and to everyone watching, and we'll hope to see you next time.
Yay, thanks so much. Thanks for having me.
Yeah.
Talk soon.